All right, so I'd like to take a moment to discuss acceleration a bit more. So far in this video series, we have seen two examples of acceleration. The first is the case of an object moving back and forth along a straight line. The velocity vector is tangent to that line because velocity is always tangent to the path. That path in this case is a straight line. And we also have acceleration, right? Because that velocity vector corresponds to the object slowing down and speeding up, and then slowing down and then speeding up, right? So the velocity vector is changing, so by definition we have acceleration, and that acceleration is tangent to the line also, because the velocity vector is changing along that line. Any difference between two sort of neighboring velocity vectors is going to be along that line. Acceleration is also along that line. And we also get this really nice result in that when the velocity vector and the acceleration vector point in the same direction, then the object is speeding up. Here they are. When they point in opposite directions like this, the object is slowing down, right? So here, same direction speeding up, opposite direction slowing down. Same direction speeding up, opposite direction slowing down, right? You get the idea. Then we also looked at this other case in which we considered an object moving around a circle at constant speed. Yes, it's constant speed. So the object neither is speeding up nor is it slowing down. Do we have acceleration in this case? Do we have acceleration here? Yes. Yes, because the velocity vector is changing its direction, right? It's constant speed, so constant magnitude of velocity, but its direction is changing because it's on a curvy path. That velocity has to be tangent to that path. The path is changing its direction. The velocity vector is changing its direction. One moment it's pointed this way, and a moment later it's pointing in a slightly different direction. And because of that, the way that change in direction works, well, the type of acceleration we get is pointed directly towards the center. It's perpendicular to the path. This is the centripetal acceleration. If you don't quite understand what's going on here, I encourage you to watch that previous video. Now I'd like you to consider a new case. Here the object is moving along a path. To begin with, I want you to observe two things. First, it's a curvy path, yes. Second, if you pay close attention, you may notice that the object is sometimes speeding up and other times it is slowing down, yes? Now, as you watch the object move along this path and the way that it's moving here, I want you to imagine what the velocity vector looks like. Can you see the velocity vector in your mind? What can you say about the direction of the velocity vector? And what can you say about the velocity vector's magnitude? Right? Think about this. Let me pause right about here. All right, let me show you the velocity vector when it's right here. Yeah. Remember, the velocity vector is always tangent to the path, right? The velocity vector is always tangent to the path. And now as I unpause this thing, we can see what happens to the magnitude of the velocity vector. When the object's moving quickly, that velocity vector is large. When the object's moving slowly, that velocity vector is small. Here the velocity vector is large again. Now I want you to think about what the acceleration vector looks like in this situation. The acceleration is the rate of change of the velocity vector. Here we have the velocity vector changing its magnitude and changing its direction. As a consequence, we get kind of a complicated acceleration vector. Let me kind of show it to you here. This acceleration has a tangential component. There's a tangential component, and it has a perpendicular component right there. So these two components added together, they give you your acceleration vector. So what I'd like to do is consider each one of these components, the tangential piece and the perpendicular piece, separately. All right, so let me clear these accelerations here so we can think about it again, and we'll unpause. So now again, I want to start thinking about just the tangential piece of the acceleration, right? Only the tangential piece. Now you'll notice when this object is entering this tight corner, it's slowing down. And then when it comes out of the tight corner, it speeds up again, right? And it does the same thing for all these tight corners on this path right here. Slows down, then speeds up. Now let me show you the tangential component of acceleration. Look at this is just the tangential piece. Yeah, do you see something going on here? Watch it, observe. It's beautiful. When the object's slowing down, look at that, let me stop it. Boom. When the object's slowing down, the tangential piece of the acceleration is in the opposite direction of velocity. When the object is speeding up, the tangential component of acceleration is in the same direction as velocity. Where have we heard that before, right? Where have we heard that? Slowing down, acceleration is in the opposite direction. Speeding up, the acceleration is in the same direction as velocity. This is the same story we had when we had motion along a straight line, right? Slowing down, opposite direction, speeding up, the same direction. Slowing down, opposite direction, speeding up, the same direction. Hence, this is the role of the tangential component of acceleration. It tells us how much the magnitude of the velocity is changing. The tangential component of acceleration tells us whether the object is slowing down or speeding up, right? Just the magnitude. Now let's consider the component of acceleration perpendicular to the path. Remember, we get a perpendicular component of acceleration when the direction of the velocity vector is changing. Right, so let me try pausing. I don't know, maybe right about here. Now I want you to tell me right here in which direction is the perpendicular component of acceleration, right? Does it point to the left or does it point to the right? Think about it for a moment. All right. Well, remember that perpendicular component of acceleration is centripetal. Right, centripetal. That means it's pointing inward towards the center of the curvature. So I should be seeing well, here it is right here. Here's the perpendicular component of the acceleration. Again, it's pointing inward. Let me put this thing in motion again. Right, always pointing towards the center. Right, as we go through this thing, it switches sides. Now it's pointing towards the right. But towards the right is towards the center of curvature right here. That curve is bending towards the right. Very tightly right there. As it passes through the origin, it switches its direction. Right? At the origin, there's this, what's it called? An inflection point where the curvature switches direction, right? So here, the centripetal acceleration is inward toward the left. Now we switch the curvature. Now the centripetal is to the right and inward. All right, does this make sense? Here we are entering the curve right here. Let me stop right there. So now we've got the perpendicular piece. Let's add the tangential piece back in. Okay, what's happening? Remember the tangential, remember as the object enters this curve, it is slowing down, right? So the tangential piece should be pointing backwards. So I got a centripetal piece pointing toward inwards, towards the center. That's my perpendicular piece. And then the tangential piece, since the object is slowing down, points backwards along the curve. And then the total acceleration is the combination of those two, right? As I plow through the curve, look, since the curve gets tighter, that perpendicular component gets larger. As we continue through that curve, look what's happening to the tangential piece. It's happening because the object is just about ready to speed up. Here comes the tangential piece pushing forward now. Again, we've got that resultant acceleration vector having, again, the perpendicular piece, that centripetal piece, and the tangential piece due to the fact that the object is speeding up. There is your story about acceleration along this sort of non-trivial path. It's this combination of centripetal acceleration and the tangential component of acceleration, which is how much we're speeding up or slowing down. Look at this dance between the vectors. I think it's absolutely beautiful. Yeah? So there you have it. That's how acceleration works. It's the sum of these two pieces.